Okay, great. So I'm Maneesh Agrawala, and I'm from here at Berkeley. My area of research is visualization. But over the last few years, I've really started to think about visualization as requiring more than just creating pictures. We really need to facilitate the interaction between people and data. And in fact, people may be even more important than the data in some ways. We've recently started a collaboration between some faculty here at Berkeley and at Stanford. Jeff Hare, myself, Joe Hellerstein, a professor here at Berkeley, and Tapan Parekh, also here at Berkeley, to really investigate how to build tools that facilitate these kinds of interactions. And the work that I'll show you today is really work that's come out of this collaboration between all of us, the faculty, and really it's the work of the students that I'll be showing in this talk. So I want to start by describing the scale of the problem that we're faced with in information visualization. There was a nice study a few years ago investigating how much data we produced in a single year. In 2010, how much data did the world produce? Gantz and his colleagues estimated that we produced about 1,200 exabytes. 1 exabyte is 1,000,000 terabytes. Okay? So over 1 billion terabytes of information were produced in 2010 alone. And in fact, this amount of information that we're producing in a single year is growing exponentially. So it increased 10 times in a span of 5 years. So this is a very, very large problem. And part of the reason for this problem is that we now have the internet connecting people, and we're recording all kinds of information about human activity. So there's lots and lots of data in the world around us. And the challenge, of course, is to be able to take the data, and as Hal Varian has said, we need to be able to understand it. We have to process it, extract value from it, visualize it, and communicate it. And that's going to be the skill that's really important for the next decades. And he says that this is true because we really do have free and ubiquitous data. The hard thing, the scarce factor, is the ability to understand this data and extract the value. So that's what we need to focus on. Now, my interest here really started with visualization. But in working on a number of visualization projects, it became clear very quickly that visualization is not just about creating pictures, but it's about a whole set of tools. We saw a version of this pipeline earlier at the beginning, but it includes a number of things that we need to do. We need to acquire the data, clean the data, integrate different data sources together, create visualizations, maybe analyze the data through the visualizations, present that information to other people, disseminate it, and so on. And we often think about these tools as working in a pipeline. We start with acquisition, then we clean, then we integrate, and go all the way through. But in practice, what often happens is that there are all kinds of feedback loops. We do a little acquisition, maybe a little cleaning, then we do visualization, then we jump back to integration, maybe back all the way to acquisition. We go around in these loops. And there's human interaction in every one of these loops. So what I want to show you today are a couple of projects that address some of the tools in this pipeline and are really aimed at focusing on how to facilitate these interactions between the different tools that are in this kind of visualization pipeline or process. And the first project I want to show is called Data Wrangler. I am, in fact, I wasn't involved in this project, but my colleagues, Joe Hellerstein and Jeff Hare, created this project, along with Sean Kendall. He's the main student. And this project is really aimed at helping people clean data. Most of the data sets that we acquire in the world are formatted in a way that doesn't make them amenable to the visualization tools that we have. There's always a cleaning step. We load in our data table into a tool like Excel and have to massage the data in a number of ways before it's ready for visualization. And this tool is really aimed at helping that process of massaging the data and getting it ready for visualization. So I'm going to show you this video that describes the project in a bit more detail with a nice example.
Imagine we are investigating property crime and download data from the U.S. Bureau of Justice Statistics. The data is not in a format our analytic tools expect. We copy text from the CSV file containing the data, paste the data into Wrangler, and click Wrangle to get started. The interface now shows a table containing the data, an interactive transform history, and a transform editor. First, let's delete empty rows in the table. We select an empty row in the table. In response, Wrangler generates suggested transforms with natural language descriptions. When we mouse over the descriptions, Wrangler previews the transforms effect in the table. Red highlights indicate which rows will be deleted. We execute the suggested transform. Wrangler adds the transform to the transform history. We'll now use Wrangler's text selection to extract state names from the year column. We select the text Alaska in row 6. Wrangler guesses we are extracting text between positions 18 and 24. It highlights matching text in each row and previews the derived column. We can provide more examples to help Wrangler generalize our selection. We update the suggestions by selecting Arizona in row 12. We execute the highlighted suggestion and Wrangler adds it to the history. We then rename the derived column State. The state column is sparsely populated. Missing values are indicated by the gray bar at the top of the column. When we click the gray bar, Wrangler suggests transforms for missing values. We can choose the next suggestion by pressing the down key on the keyboard. We can execute the suggestion by pressing Enter. We now remove the rows containing the text Reported. We select the text Reported in row 12. Wrangler suggests extract, cut, and split transforms, but no delete transforms. We can reorder Wrangler's rankings by clicking the delete command from the rows menu in the transform editor. After executing the command, the data is in a relational format. We'll now create a cross-tabulation of crime rates by state and year for subsequent graphing in Excel. We'll use an unfold operation to reshape the data. Unfold operations are similar to pivots in Excel. We select the year and property crime rate columns. We find an unfold transform in the suggestions. For operations that alter the layout, we preview the result with the ghosted overlay. We execute the suggested transform. We can export the transformed data to analysis tools such as Excel, or we can export the transformation itself. The output of Wrangler is a declarative data cleaning script. From this high-level script, we can generate code for a variety of runtime platforms. On the right, we show generated JavaScript code.
Okay, so that's an example of a tool where we've built a UI to do the cleaning, to help to interactively work with a user to clean the data. And the UI generates this kind of script that can then be applied to a very large data set. And we believe that this is much better than having to manually go into a tool like Excel and meticulously clean and format the data in a manner that's appropriate for creating visualizations. And you got a sense for how quickly people could do that using Data Wrangler. In fact, well, let's just go on to the evaluation. My colleagues have compared Wrangler to Excel. It's much, much better, faster than simply working in Excel. In fact, what's interesting, they show in their study that skilled Excel users benefit even more than novice Excel users at when they're using Wrangler. So you might expect that this would be an especially useful tool for novices, but in fact, if you have some skills in Excel, you're even better. That tool is available online, so if you're interested, please check it out. And I will move on to the second project that I wanted to show you. And this one is called Comment Space. And this was really developed here at Berkeley, but along with Jeff Hare at Stanford. So this project addresses the following issue. In the last few years, we have seen a number of systems that allow online collaborative visual analysis of data. Many Eyes from IBM is one example of this kind of a system. And the way Many Eyes works is that you can load in your data, create a visualization, in this case showing the social network of the Bible. And then users can come and see your visualization, and they can leave comments on it under the visualization, sort of below the fold. And what we hope for is that people will use this kind of commenting mechanism to analyze the data and leave insights about it, maybe hypotheses about why the data is the way it is, and evidence for and against those kinds of hypotheses. In practice, we see very little such analysis. Okay? In practice, these tools are not all that great for analyzing the data. And what happens is that there are a number of shortcomings. In particular, users have to scroll up and down to leave their comments. The comments are not tightly coupled with the visualization. It can be difficult to find comments that are useful, to organize the comments, and so on. So these tools haven't been extremely effective for analyzing the data in the wild. Now, there have been research prototypes that are a little bit better. This is Jeff Hare's census system. This is showing employment data over the last 150 years in the United States. And here, they solved a very important problem. They tightly coupled the comments, which are over on the right, with the view of the visualization. So here is one comment about this view of males in the workforce. And in this video now, we'll switch to women in the workforce, and we get a different set of comments, and the comments are very tightly coupled to what you're seeing in the visualization. Okay, so it solves the coupling problem, but it still has a number of issues. It doesn't help with really structuring the comments, organizing and grouping them to do hypothesis generation and evidence finding. So what we wanted to do is go a step further. And our research question is, can we develop social data analysis tools, these kind of collaborative tools, to support deeper kinds of analytic reasoning? And our approach here is to augment the commenting tools that you've seen, that I just showed you, with lightweight structure. So here's how our system works. It's organized similar to census, but here we have a visualization of the Billboard Hot 100 over the last 100 years or so. 50 years are being shown here. We see Elvis Presley. Each one of the yellow lines represents a song. And you can see how it rose and fell in the Billboard Hot 100. And here someone is leaving a comment that says, well, Elvis was undisputably the king of rock and roll. Any evidence to the contrary? So this is just like the previous system, census. I can leave a comment that's tightly coupled with the visualization. But I can go a bit further. I can add lightweight structure. So here, I'm going to tag this comment as a hypothesis that Elvis is undisputably the king of rock and roll, and also a question. Is there any evidence to the contrary? Okay, so that's a form of lightweight structure. Now someone else can come in, look up the Beatles, and say, link it as evidence against. So she says, well, Elvis had a much longer run, but the Beatles had many more hits in a short span of time. right? So she's arguing against this first hypothesis in question. And another thing we can do is after there's been a bunch of comments have been added to the comment space, we may want to go in and reorganize the comments. So here there's a comment about Michael Jackson's hits, and we want to put them closer to these comments about Elvis. This is also evidence against Elvis being undisputably the king of rock and roll. And this kind of reorganization can help us gather evidence for and against a hypothesis. Finally, comment space allows filtering tools. So I might be interested in just seeing the hypotheses about a data set. I can click on hypothesis, evidence for those hypotheses, and now I've reduced the set of comments to just the ones that I care about. So these kinds of tools are extremely important, and we believe can further facilitate collaborative data analysis. Now, I want to point out that we've chosen a very specific set or vocabulary for the tags and links that we provide. These are aimed at hypothesis generation and evidence gathering, and this slide kind of describes the tags and links. The system is general. We could provide any set of tags and links. We've chosen these because they're relevant to the kinds of analytical tasks we're interested in. The other thing that's very important about comment space is that it works with any visualization that has a mechanism for setting the state and getting the state of the particular view of the visualization. The way this works in practice is that we encode the state of the visualization, the particular view that you're looking at, within the URL of the visualization. And that allows comment space to work in a general way and really tightly couple the comments to a particular view of the data. So here's an example of that. This is a visualization we created of the medals in the Olympics, country by country. And someone else might find evidence for or against some of the hypotheses on a Wikipedia page. They can link in the Wikipedia page and continue the discussion that way. Here's another set of data from Google's Public Data Explorer that might be relevant to the discussion. It can be linked in, and all of the discussion can just happen in comment space. Okay, so we have done some evaluative studies. We had two conditions: people using comment space with the lightweight structure, the tags and links that I showed you, another group using it without the structure. And in a series of 3 tasks, we found that comment space does facilitate collaborative analysis of the data. We had 3 tasks in particular in the study. In the first task, users explored the data set, interactively kind of went through it, and left comments on it. In that stage, there was no difference between the 2 conditions. In a second stage, we asked participants to look at existing comments and organize them, group them together, figure out chains of evidence, and so on. And people spent more time in the tool comment space where they had tools for organizing. And then finally, we had a synthesis stage where we asked people to, again, look at the comments and synthesize them into a final summary of the discussion around a particular hypothesis. And the syntheses were longer and rated as better in the tag condition. Comment space is on the web. You can check it out and see what it's like. And we'd love to hear your feedback and what you think about it. And I will leave you with one final slide. This is, again, as I mentioned at the beginning, a new research project that we're starting, really trying to understand the interactions between people and data. And a lot more information about the projects that I've shown you here are available at this URL. So thanks a lot.
Hold on for just a second. Questions? Yes, sir. And just wait, if you would, just wait a moment for the microphone so that we can capture.
Hi, I would suggest that a good place to test the comment space would be in an organization trying to lean out its services. where evidence for hypothesis generation and all that is part of the transformation of business process or organizational process.
Yeah, I think that's a great suggestion. If you have a organization and are interested in trying it, we'd love to talk to you.
One other question here? Yes? Hi, Mark.
Yeah, you showed the data Wrangler tool, and you showed some automatic analysis of rows that it recognized. Does it also do it on a field basis? Can it recognize if the data cells are polluted? So if commas are in places where it shouldn't be and clean that up?
So it'll try to do the matching and parsing of the data. If there's an error in the parsing, the user has to find that error, see that error in the example that it's showing, and then try to correct the error. So it's really interactive between the user and the system.
Maneesh, thank you very much. We will be taking a short